Good afternoon, good morning, everyone. Let's start with my introduction. Myself, Somesh, working as a senior software engineer in ADS project, Ario IT Solutions, Hyderabad. Today, I'm going to explain the database related topic, that is adaptive query processing. What is meant by it? Simple. To optimize the performance of the queries by adjusting the execution plan dynamically at runtime conditions and factors of query execution. Let's share my screen. This one, adaptive query processing. Optimize the performance of the queries by adjusting the execution plan at runtime conditions and factors of query processing. Before getting to this topic, just I need to give the brief information about query SQL Server compatibility levels, database scope configurations, and execution plans. So that I have prepared the agenda like this. This is the today agenda, which we are going to explain about the database scope configurations, database compatibility levels, execution plans, and our legend topic is adaptive query processing and configurations of adaptive query processing demo and queries. So now get into the database scope configurations. Database scope configurations are introduced into the SQL Server 2016 in the version and by the Microsoft. What is the use of this Microsoft introduced these database scope configurations are applied at a database level and provide the more granular control over the specific behavior. What is exactly granular control over database? To configure certain options at individual database level. For example, max top, what exactly it is? Maximum degree of parallelism, which controls the number of the processors, maximum number of the processors that can be used to execute a single query in parallel. For example, I want to make it as a 4. So the database instance can execute the single record or single query. It can be divided into the 4 portions. Portion 1, 2, 3, and 4. These are executed parallelly. So in traditional years, it is set by the instance level. So that means it can be applicable to all the databases into that particular instance in traditional years. But on the 2016 version of the SQL Server, Microsoft introduced database scope configurations. That means you can check this option only specified database. Specified database that can be applicable to the database individually. So nowadays, till we have the SQL Server 2022 version, we have the 33 configurations are available. So these configurations are settings are supported to Azure SQL Database, Azure SQL Managed Instance, and Azure SQL Server 2016 onwards. This is about the database scope configurations. And next one is database compatibility level. What it is? It is to determine the version of an SQL Server. It is also one type of the database scope property, configuration property, so that it can be used to interpret the transact SQL statements. Now I am giving to the single snapshot here. See, in SQL Server 2022, we have the recommended and compatibility levels and supported levels. In supported levels, up to 150 is the recommended level and up to supported to the 110. 110 is the SQL Server 2014, 120 and 110. Here in SQL Server 2022, it can be supported to SQL Server 2014 version feature also. Like that, I have mentioned here 2019, 17 and 16. See, these are the recommended levels. 19 is 50, 2017 is 140, 2060 is 130. Likewise, supported levels are these as per the versions. This is about SQL Server compatibility level and execution plan.
Yes. Can you go back to the what is it supported compatibility levels means?
Supported compatibility level means for every SQL Server version, we have some recommended level. Actually, whenever work with an SQL Server 2022, the compatibility level is recommended to the 150. but I want to work with an SQL Server 2019. SQL Server 2019 is also supported 140. For example, 2014 it is 120. I have this version in my system, but I need to enhance this. I need to use these features in 2014. So I need to set the compatibility level to 110 in this SQL Server version. So it worked like a SQL Server 2014. So I'm here. This is a database property to determine the version of an SQL Server database engine.
Yeah.
Basically, this is used for upgrading to the new server.
Yes.
When we are upgrading from older to new servers.
Yes.
So in a more simplistic way, guys, when you create your database, your project using SQL Server 2016, you will have a set of instruction in Transact SQL that you have available in that version, that compatibility level 130. But when you upgrade your server to the in example 2022, you will have a greater compatibility level, which is 150. That means that you have more instructions available. The set of instruction is greater than you have before, but you are safe because the SQL Server 2022 it's supporting the 130. But if you have something before 2014 and right now you are upgrading to 2022, you have to upgrade your compatibility level and the thing that you have developed in that compatibility level before that. For example, compatibility level 100, you will have to review your code because could be some instructions in the Transact SQL that won't work anymore.
Yes.
This is the thing.
Yeah. Thank you. Our next, execution plan. In database engine, when we are running any query, the execution plan is generated. So it is a detailed blueprint of an SQL server for executed query plan. So query optimizer to create this execution, create and execute a SQL query. Simple. It is a blueprint of any execution query. It is created by the query optimizer. This query optimizer, what does query optimizer? It analyzes the structure of the query and available indexes and various other factors to determine the most efficient way of the execution plan and to retrieve and process the requested data as an outcome. So, and we have the query execution plan have some components. What are those? These components are building block of the query execution plan representation. So, for example, we have the table scan and clustered index scan, index seek and index scan sort or hash match. All these things will be there. So, for example, table scan. If it doesn't have any index on a table, the database search engine to check each and every record into the table. Actually, it is bad for the performance. For smaller database sets, it's good for the performance wise. At the same way, clustered index scan. For example, I have a index on a column. That column I want to retrieve some data from using when select query. Then automatically it performs the clustered index scan. For example, index seek. In this index is I have created a one clustered index or non-clustered index on a particular column that can be used into the where condition, where class. Then it performs the index seek operation. Likewise, each and every operator or component having the different mechanisms to represent the query execution plan. And next, types of the execution plans. In database engine, we need to visualize this estimated execution plan and actual execution plan and query statistics. These three can be available in the database engine inner side. So what is the estimated execution plan? Before running the query, we need to check the estimated execution plan. For that, nothing but predicting something. In actual execution plan is to generating the execution of a particular query at real time. It provides the real time information, that means resource usage, rows count, and other metrics. And parallel execution plan, it is related to the maximum degree of parallelism, which I have earlier discussed. So query optimizer has to choose to execute the particular query in the multiple threads simultaneously. So performing the portion of work. For example, I want to give you a maximum degree of 4, each portion having the each thread that can be performed in the 4 threads to executing the single query. Serial execution plan. It is related to quite opposite to the parallel execution plan. Only single thread can be used to execute the particular SQL query. And cached execution plan. In this, to avoid the recompilation of the query. So it is get it from the DB cache. And live query statistics. So to monitor the what happens. For example, I have written a query in the database inside. I just want to execute. Then what is the process and what are the visual representation need to know. So we can use this live query statistics to check the and monitor the query execution flow. And this is about types of query execution plans. And today our legendary topic, adaptive query processing. So in adaptive query processing, this feature helps to optimize the performance of the queries by dynamically adjusting the execution plan and based on the runtime conditions and factors. So and also this feature improves the performance on workload straight out of the box because there is no code changes required to implement this. And also to address the number of challenges to optimize the complex and dynamic data environments. And this feature is only apply for the select statements because we need to write a select statement to get the particular output. There is no other like DML operations like insert, update, delete. We don't want to need them. Only select query is invoking for this adaptive query processing. So and also we have some configurations available under the adaptive query processing. Those are batch mode adaptive join, interleaved executions, and memory grant feedback. So these 3 can be introduced in the SQL Server 2017. And first one is batch mode adaptive join. The main aim of this batch mode adaptive join is to choose whether the hash match or nested join dynamically at runtime. It is based on the number of rows processed in the system. So here hash match and nested loop join. In earlier versions, database engine or query optimizer need to predict to check take the hash match or nested join. But here we are giving the instruction to the query optimizer to choose the particular hash match, either nested join. With the help of this, it is estimate number of rows significantly different from the actual number of rows returned from the executions. So how can we database engine choose this hash match and a nested join? Here they are mentioning the adaptive threshold rows. So adaptive threshold rows, based on these, if the row count is less than the adaptive threshold rows, the query optimizer choose the nested loop join. If rows count is adaptive threshold rows is greater than, it choose the hash match join. And I'm giving the 2 types of versions, SQL Server 2016 and SQL Server 2017. While changing the compatibility level, I need to give some live demo as of best of my knowledge.
What is this adaptive threshold?
Which one?
Adaptive threshold, what is that?
Adaptive threshold, this is related to the how much data is processed. So based on that, query optimizer need to identify the count of rows. I'll show you in the demo.
Okay.
And there is a hash map, right? Hash map?
Hash match.
Hash match, okay. Hash map or a hash match?
Hash
match.
Okay, that it is in memory, right? So it is you put it in the bracket, it's in memory.
Actually, hash match, it creates a table that is in memory.
Mm-hmm.
The operation of the hash match is like this. This is the hash match join. it creates the table that is called in memory. Based on that hash table buckets, this is our problem input. Based on this problem input, it creates inner table. This is inner table. This is our problem table. It matches to find the matched item from these two already created by the match table, and this is the problem input. Based on this, whenever we find the matches.
So how it is automatically dispose the the other ones, like, because it is again optimization, right? So when we say an optimization, it should be able to memory is the one constraint always, right? Whether it is a RAM or a solid state, like in a disk level memory and RAM level, right? So again, that makes a lot of difference.
Yes, that is also should considered in the adaptive query processing in the memory grant feedback.
Oh, okay.
I'll explain later session.
Okay.
So I'm just sharing my screen. See, I have just prepared some script. I'm using the worldwide importers database. I want to check this database compatibility level. So it is 140, but 140 is related to the SQL Server 2017. So I need to make it as SQL Server 2016. So now check. So it would work like an SQL Server 2016. And also I'm checking the adaptive configurations. So batch mode adaptive configuration is also off. For 2016 version, I need to off the, batch mode adaptive join should value will be 0. That means off. I need to check with this query. I'm just enabling the actual execution plan. See, in 2016 version, database optimizer can choose automatically based on without any proper instructions given by the user. So it automatically chooses a hash match.
Is a memory utilization here?
This one. And now I make it as SQL Server 2017. The compatibility level is 140. And adaptive join is on. I'm just running the same query again. See, this is an adaptive join.
Is there anything in the path, change in the path?
Yes. Actually, in this adaptive join, to choose the based on the threshold value, based on this one. Whether if it is less than the threshold value, it choose the hash match. If it is greater than, it choose the nested loop join. That is, instructions is given by the database configuration level, which is by the user.
So how here adaptive is like in which scenario or a use case, how do I do this threshold set?
For threshold set, it is automatically processed record based on the processed records. It's done by the query optimizer.
So can we modify that, or this is like predefined and we are using that?
No, we have the option. We have the option to choose. We have the option to choose whether it is hash join and nested loop join. It is done by the query optimizer, but we need to set the database configuration with the help of batch mode adaptive join. For example, if it is off, in the version of an SQL Server 2017, I'm just running the same query. So here it takes a hash match. We are not instruct. It's automatically taken by the query optimizer. So to overcome such kind of things, Microsoft introduced batch mode adaptive join is on in the version of SQL Server 2017. Then it based on the threshold value. Threshold value we can get it from the how much data is processed. Based on that, threshold value will be defined by the query optimizer.
So by default it is off.
2016 it is off. 2017 by default it is on, I think.
Why is that? Like, is there any memory like utilization? Because for the large data sets.
Yes. For example, I just want to update the some condition. See, this query can choose the nested loop join.
What is the query updated?
Yeah, it is query updated. So physical operation is adaptive join, and actual join type is nested loops. Here that adaptive threshold rows 186. So based on this can be defined by the query optimizer.
So it automatically resolves, right? Depends on the query.
Data. Yes.
Data.
For example, in previous query, it returns how much records?
So what is the total size of the data set then?
Actually, I'm not.
24,000.
Actually, this data set size is 24,000 records it returns. And this returns only single row. So it returns single row, but threshold value based on that total number of records processed, so that it choose the nested loop.
These are the two methods which automatically resolve, right? Depends on the transaction.
Yes. While setting this option into the database configuration section.
So it improves the performance of the query. Like
yes.
The response can be improved, right?
Yes. And next one is interleaved executions. This is the second configuration option. In adaptive query processing. What exactly it is? It is just this feature helps pausing the execution long enough to capture the more accurate cardinality. That means if any SQL statement, we are using the multi-statement table valued function, that execution plan fixed to the estimate number of rows is 100. No matter how many rows the function might return, because this function returns the number of rows, but execution plan and estimated number of rows should be set to the 100. To overcome this drawback, Microsoft introduced this interleaved executions. So it is smaller data sets, it is okay, but in the huge data sets, its performance could suffer. To overcome this, they are introducing the interleaved execution feature in the version of 2017. I'll show you that one. So this function, multi-statement table order function, I have already created.
This is a user-defined?
Yeah, it is configuration setting by the user.
The function is a user.
Yeah, user defined this one. Just which is created by us. Just it returns the information related to the quantity which are passing the particular value is greater than that particular quantity. Just select query. So I want to make this changing the compatible level to SQL Server 2016. Checking 130. And interleaved execution option, it is enabled. So I just want to off in the version of SQL Server 2016. I'm just running this query. Enabling this execution. See, this is table valued function. It is set to the number of estimated rows per execution. All execution it is set to the 100. How many rows should process this function? 9,000 records should process. So to overcome such type of things, the Microsoft introduced this configuration, interleaved execution TVF. This option that will be shown to the SQL Server 2017. I want to make the compatibility level to 140. Just want to on that particular option. Now check whether it is enabled or not. I'm running the same query. See.
The estimated cost is increased now.
Yes. Estimated cost is increased. Total number of rows also processed same. Actual number of processed 24,459 and estimated number of rows also same. Before that it is set to 100.
So what's that meaning actually? 100 per execution means what?
For example, I have a huge database, huge data set. I want to run a query. It returns number of rows. Before executing that particular query, I just want to know how many rows are affected. Just without this option, it is set to 100, no matter how many rows are processed. So
it is like a pagination.
Yeah, the execution plan is fixed at 100, but no matter how many rows the function should make a return.
Mm-hmm.
So for that scenario, this option should enable in the version of SQL Server 2017, so that the estimated number of rows should be same and actual number of rows should be same. And third one is memory grant feedback.
I have a question actually. How means this is means applicable for us? Means if I am suppose running a use query,
okay,
how it will help me actually as a developer? I'm asking.
For our databases, we have the multi-statement table valid functions, right? You need to enable. You can do the one scenario like with the help of SQL Server versions. You need to check the SQL Server version first, and you need to create a one multi-statement table valid function that can be executed in the database itself. You need to off this particular option, interleaved execution. Now check how many records should processed for the estimation, how many records should processed after the execution of the query. So you need to get a clear clarity because estimated records should always set to 100 without this option.
That I got that whatever you explained steps and those things. What I am running, I am a suppose developer. I am running a huge query procedure, something that is returning so many records.
Okay.
By using this interleaved execution, how it can help me actually as a developer? How it can help me? That's what I am trying to understand.
For example, if based on the data, because huge database will be there, estimated number of rows, because database should want to estimate the number of rows is 100, but no matter how many records should processed for that function. It will help to, you need to know that configuration settings.
Yeah, but in a simplistic way, if you're a developer and you have those configurations enabled, you will receive more accurate statistics. So if you are trying to optimize your query, the information that you're getting from the execution plan is more accurate.
Yes.
Okay, got it.
So for this point, this feature helps to pausing the execution long enough to capture the more accurate cardinality. And third one is memory grant feedback. memory grant feedback. It is the third configuration settings in the adaptive query processing. For every SQL server uses some memory to store the raw data during the join and sort operations. So while compiling the execution plan, the query engine estimates how much memory is needed to store those rows. So for example, if the memory is estimated too small, then exceeds the data spill over the disk. So impact the performance here. If the memory is too large, memory is got wasted. So impact the performance of concurrent operations. So avoid the such kind of things. The Microsoft introduced the memory grant feedback feature in a version of 2017. It helps to recalculate the raw memory as per the requirement when the statement is first executed. For the first time, initial estimate it should be off, because after that the catch plan is updated. After the first execution, next the subsequent executions it can be benefit from the new estimate as long as query plan is remains the same in the caching. For the first time it got off. After that it will enable and it show the how much memory is needed for that particular query to store the raw data. So I'll show you that. Here also I'm using the two compatibility levels. One is for 2016 and it is disabled. I need to clear the cache procedure also.
So, the estimate is excluding cache, is it?
That is not mentioning in that scenario actually. So I have already created this SP database itself. Now we are running this query in SQL Server 2016 version. See here memory grant. For running this query for memory grant is 172 MB in the version of 2016. Again I'm running the same query. It is also 172 MB. Again I'm running the same query. It is also 172 MB. So now I'm just want to change my compatibility level to the SQL Server 2017 and this option is enabled. Now running the same query. For the first time it is off. It is taking from the 195 MB memory grant. For subsequent executions, it takes 193 MB. Again 20 MB. And again 20 MB. So based on this configuration level, because already the data query execution plan is stored into the cache, so that for every time subsequent executions it takes 20 MB. So for this option, the query optimizer estimate what the memory is required.
Like the criteria change, like where condition or some inputs change, right, in the query.
Yes.
Again, it's going to estimate, right?
Again, first time it estimate the new execution plan.
But in real cases, like, so the query is going to change, right? Based on the parameters.
Yes.
So it means that every time it's going to estimate, right? So there is no retention, because the query cannot be
Yes.
maintained. We no need to retain the same query and again executing again and again, right?
Yes.
And let's say if it is something which calculating a valuation, right? When we are calculating a valuation, something, the parameters are going to be different for each valuation,
Yes.
right? You cannot execute the same kind of set of inputs for the same result, right? So the inputs are going to be changed, means the estimate is also going to change, right?
Almost. Because
So-
number of records processed would be different, right?
So the use case, like whenever there is, a kind of a content where that is repeated request, then this is going to be like,
Yes.
Memory cache response is one of the attribute, right? In our .NET C#
Yes.
kind of
But
thing.
yes. So see, in this last point, they are said like the subsequent execution can benefit from the new estimate. So as long as query plan remains in the cache.
So in case the inputs change, the estimate supposed to be done, right? Again and again.
Again, supposed to be done. Yes, it is used to benefit from the new estimate.
All right. But this is like, if it's a media news channel, like if they create a new the content is there, the user is hitting the same news article, the same thing is going to be fetched in a quicker way, right?
Yes.
Yeah, this is something that could be pretty technical, but what the database is catching is the statistics and the execution plan, not actually the result. So doesn't matter if you change the input parameters, because the database always run the same execution plan. This is one of the benefits of those executions plans when you use SQL Server. If you change something in the code of your query, if you change one inner join by a left join or something, the execution plan needs to be recalculated. But otherwise, no.
Okay, so the structure till the structure change, right? The how it is the query laid out, right? So till the same plan is going to be the same. The statistics will remain the same, right?
Yes.
Whatever the predicted, that is going to be the mostly actual.
Because execution plan will not change till we'll not modify it, right? So once we'll modify, then only execution plan will change.
Right.
Yeah. More execution plan and statistics.
Yeah. Logic change, when I make it, when I can say this. In case the logic change, the plan changes, right?
Yes, correct.
So whatever the plan estimated, that is going to be remain, for irrespective of the value of inputs, input values.
Yeah, one database will use the execution plan, statistics, and the indexes to retrieve your information, right? So statistics and execution plan shouldn't change if you don't change your code.
Right.
But indexes can be degraded. Indexes are nothing but tables aside that you keep or maintain when you are keeping the pointers to your actual record. So those indexes will degrade during the time, because you will do updates, you will do deletes, you will do new inserts. So the query performance will be degraded, depends on those indexes as well. Doesn't matter if you haven't changed your code, the statistics are the same, the execution plan is the same, but the indexes are degraded. So that's why the DBA should run something to rearrange all the indexes in the database frequently.
Yes.
Okay.
So that's all about today's session. So I'm getting the references from redgate.com and SQL Shocks. These are the websites which are getting the information from about the adaptive query processing. And any queries? And thank you.
Thank you so much, Somesh. It's a lot of information. Very helpful. Yeah.
Yeah, sorry
Yeah.
guys, I just joined. So is this session recorded?
Yes, it
Yes.
is recorded.
Yes.
Okay, thank you.
Thank you so much, Sivi.
Thank you.
Thank you.
Thanks, everyone.
Thank you.
Thank you.
Thank you all.